Fire insurance. Suppose that you work for an insurance company and you sell a 100,000 fire insurance policy at the annual premium of $1,350. Experience has shown that the probability that total loss due to fire to a house in that area and of the size of your customer house is 0.002, in which case the insurance company will pay the full $100,000 to the customer. The probability of 50% damage due to fire to a house in that area and of the size of your customer's house is 0.008, in which case the insurance will pay only $50,000 to the customer. For simplicity, we'll ignore any other partial losses. Let the random variable x be the insurance company's annual gain from such a policy, the amount of money made by the insurance company from such a policy is called the annual gain. Part A, find the probability distribution of x. Now, x is the annual gain, but it also assumes that the annual loss in this case, we were given two scenarios, total loss or 50% damage. However, if the insurance pay every insurance policy, then how are they going to make money? Well, although it is not explicitly stated, there are a lot of customers who do not have the payout from the company, meaning there are lots of customers who pay a premium each year and not get anything in return. And that is how the insurance company make money. And so part A, to construct the probability distribution of x, we would consider three cases. One is when the customer do not get anything back, and so the insurance company would get the premium 1,350, and that is again no accident, no fire, no damage. And then for the total loss, the insurance would take 1,350, but they pay 100,000. And for the 50% loss, the insurance would take 1,350 from the premium and they pay 50,000. Now, let's just rewrite this. The insurance would gain 1,350 if there is no damage. If the total damage, the insurance would lose 98,650. This is 1,350 minus 100,000. And if there's a 50% loss, the insurance would lose 48,650, and that is 1,350 minus 50,000. And so we have three cases, and we will also list the corresponding probability to complete the probability distribution for x. The probability of total loss is 0.002. The probability of 50% loss is given 0.008. And we were told that there is no other partial loss. We know that from the probability distribution, the total probabilities need to add up equal to 1. And so what is the probability of no damage at all? 1 minus 0.002 minus 0.008 is 0.99. And so there is 99% chance that the insurance does not have to pay anything. This is a probability distribution of x. Most likely we do not need the first column. We only need to list these x column with the corresponding probability. What is the mean or the expected annual gain for a policy of this type for part B? To find the mean, we just simply take the x value times the corresponding probability, and we would do this for each row in the table. Negative 98,650 times 0.02, and then negative 48,650 times 0.008, and we add them all up. We will get $750. And so in the long run, or if the insurance company sell many policies, they expect to earn $750 annually for each policy. Part C. The insurance company gets information about gas leakage in several houses that use the same gas provider that your customer does. In light of this new information, the probabilities of total loss and 50% damage that were originally 0.02 and 0.08 respectively are triple. And so the new probabilities are now 0.006 and 0.024 for total loss and 50% loss respectively. If we take 0.006 plus 0.024, then we get 0.030, and so 1 minus 0.030 will get us 0.97 for no loss. Obviously, the change in the probability should be reflected in the annual premium to account for the added risk that the insurance company is taking. What should be the new annual premium instead of $1,350 if the company wants to give the expected gain of $750? In this case, we have to find what would be the adjusted premium. We don't know what it is, so we would let this new expected premium to be N. And so we will replace $1,350 with N. And if we do that, we would have the following equation. This time, since we do not have the premium amount, we cannot use the information from the second column. We will start with N times the corresponding probability, 0.97. N is the premium. This is what the insurance would gain if there is no damage, times the corresponding probability, plus the insurance would take N, the premium, and pay out $100,000 for total damage, times the corresponding probability, which is now 0.006, plus for 50% damage, the insurance will take the premium, which is again unknown N for now, minus 50,000, times the corresponding probability, which is now 0.024. And they want to keep the new expected value as the same as the old, so equals 750. We now just need to isolate N to get the answer. So this is 0.97N plus 0.006N, where we distribute 0.06 minus 0.006 times 100,000 is 600, plus similarly 0.024 times N is 0.024 times N, minus 0.024 times negative 50,000 will give us minus 1,200, equal to 750. We then group all of the terms with N, combine like terms. We will take 0.97N plus 0.006N plus 0.24N, and that will give us 1N, equals, on the right hand side, 750, and we move all of the other numbers to the right hand side. Negative 600 move to the right, becomes 600. Negative 1200 move to the right to get plus 1200. And so N equals 2550. This means if the insurance wants to keep the same expected value, $750, they would need to increase the premium to $2,550.